Good day to all of you. Today we shall study Cartesian product operation from Relational Algebra in DBMS. Let's start the session. First, let us know what is Cartesian product, which is represented by cross symbol. In database management system, Cartesian product or cross product is an operation. It combines every row of one table with every other row of another table, resulting in a new table with all possible combinations. That is, it merges columns from different relations or tables, producing a result set with all possible pair of tuples or rows. Cartesian product is also known as cross product, cross join, or Cartesian join. So in simplest terms, to understand overall what the Cartesian product is, let us consider two relations R and S. Then cross product of R and S relations is, so this is the row in first relation, this is the row in second relation. So first row is combined with first row of second relation, so that is put in product relation, means here A, B, C, so of first row in the first table, and D, E. So these are the row elements from second table. So both are combined and one row in the product relation is generated. Next, this first row only is taken, that is joined with second row here. So A, B, C, here 4, 5. So if any other row are there, so this is joined and next this is joined. That is how next rows are generated in the cross product. If there are 8 rows in the first table and 3 rows in the second table, every row in the first table is combined or joined with every other row in the second table. That is why in product relation we will have 8 3s are 24 rows. So in short, I have dealt with cross product or cross join, which name I have used throughout the video session next, but that also means Cartesian product. Okay, so next we shall see with an example in detail about Cartesian product or cross join or cross product. Okay, to understand the concept, let us take an example. For that, the inputs that we take are two relations or two tables. First one is enroll table, second one is student table. Student table has student details like SID, that is student ID, and S name for student name. So SID and S name are column headings or attributes, and this is the 3 students details which is stored in that student table. Then enrollment table has the student has enrolled to which subject. So here student ID is there, and to which subject or course that student has enrolled, we have here course ID, that is CID. For example, S1 student has enrolled to subject or course C1, and S1 student also has enrolled to course C2. S2 has enrolled to only one subject C1, whereas S3 has enrolled to 3 subjects or courses C1, C2, C3. So this is the enrollment information of the student which is stored in enroll table, and student table stores the student details, that is student ID and student name. So these two tables or relations as input we shall take for our next example, which we are going to discuss for understanding cross product or cross join concept. Okay. So if this relation is R and second relation is S, the cross product or cross join of R and S relations is written as R cross S. So we have now cross product of enroll and student relations. So that will be this relation. Okay. So this is the resulting relation from cross product of enroll and student relations. So one should always remember that relation means table, tuple means rows in the table. Okay. So if you do a very keen observation, so from enroll table, first row means S1 C1 joined with first row of second table S1 allies elements. So S1 C1 S1 allies. So these two are from first row of first table. This is from first row of second table. Now this first row is joined with second row, then first row is joined with third row. So S1 C1 S2 Bob. So S1 C1 S2 Bob. S1 C1 S3 Charlie. S1 C1 S3 Charlie. So this part of the product relation is from first row elements with first row of second table, then second row of second table, then with third row of second table. This is how we obtain this part in the product relation, and this procedure must be continued for all remaining rows of first table. That is, every row of first table is joined with every other row of second table. So that is what will be done in product operation or cross join operation. So this is cross product or cross join operation. So that we shall continue and see now. Okay. So what is done? First row is taken, it is joined with first row of second table, and first row in the product relation is generated. Next, first row is joined with second row in the second table. So next row in the product relation we have. So first row in the first table is joined with third row in the second table, and hence next row in the product relation is done. So this is with first row operation of the first table. Next, second row of first table is joined with first row in the second table, and next row in the product relation we have. So first row in the first table is joined with second row of second table, and hence next row in the product relation is generated. So then first row is joined with third row in the second table. So next row in the result relation or product relation is obtained. So this is the procedure that is over with the second row in first table. This must be repeated for third row in the first table. It should be joined with first row in the second table. So next row in the product relation is generated. Then that is joined with second row in the second relation. So next row in the product relation is generated. So it is joined with third row, and hence next row is generated. So this completes the procedure with third row in the first table. So it must be now continued for the fourth row in the first table, that is enroll table. So this time S3C1 should be taken, and that is taken. It is joined with first row of second table. So S3C1 and S1 allies we have in the next row of product relation. So S3C1 row is joined with second row in the second table, and next row in the product relation is generated. So it is joined with third row of second table, and next row in the product relation is generated. So procedure is over with that row of the first table. Next row, that is S3C2, is taken, joined with the first row of second table. So next row in the product relation is generated. So with second row it is joined. So next row we have in product relation. With third row it is joined, and we have next row in the product relation. So this completes the procedure with S3C2 row of enroll table. So the last row in the enroll table, that is S3C3, that will be joined with first row of student table. So that is kept in product relation. Next it is joined with second row, that is kept in product relation, and lastly it is joined with the third row of second table, and the last row of product relation is generated. So that completes the procedure of obtaining the cross product of enroll and student relation. So the procedure of obtaining this cross product is over now. Okay. So we had started discussing what is cross product or cross join. We had taken these two example relations to understand cross product of enroll and student relation that we have here. So what is cross join? Cross join or cross product operation joins every row of first table with every other row of second table. So here if you observe, in the first table we have 1, 2, 3, 4, 5, 6. In the second table 1, 2, 3. So here 6 rows, here 3 rows. So first row is joined with 3 rows, second row is joined with 3 rows of second. This way all the 6 rows, when they are joined with the second one, we will have 6 threes are 18 rows in the product relation. So these are the 18 rows which are obtained by the cross product of enroll and student relation. Okay. So that completes the discussion of cross join or cross product operation. It forms the basis for all join operations in DBMS. In many practical applications, join operations will be used. For that, understanding of cross join or cross product is very important. You please once again go through the video for the given example. On your own, you try to write your resulting relation and you should arrive at this result. Okay? I hope you understood. Thank you.